equation, write it out, substitute in our formula for friction, force normal times mu, and then I solve for the coefficient of friction once I put the numbers in. Remember, the coefficient of friction does not have a label. So if you don't remember that, maybe just write a learning point down. Okay, so now we need to go on and do C. Let's go ahead and do C together. It says, what would the acceleration of a sled with u of 0 be? So now we do have an acceleration, and mu is 0. So mu is 0. So now it's not 1/6. So now I have to go back to my equation right here, and this is no longer going to be a 0 anymore. Okay, so I'm going to go back to my original equation and write that out. I have 300 times 0. What my force applied to be. Mass. How do I go ahead and find my mass? What am I going to do with my force of weight here? I'm going to take 300 divided by 9.8. What do you get? You get 30.61 kilograms. So we're going to put that in. That's 0. So what does A end up being? Right? Do you agree with my number or not? Want to talk to me? Do you agree with my number or not, guys? Yeah, awesome. Okay, so number 2 is just like number 1, except it is a modified Atwood problem. So where do we do a modified Atwood problem with number 2? Where in the past have we done a modified Atwood problem? If you look back at sheet 4.
Number 5.
Number 5. So you're going to do number 2 for today. That's going to be part of your homework for tonight. Okay? So do number 2. Number 2 on page 234. So then we're going to turn the page, and we're going to look at number 3. Okay, we're still on a level 4. Level floor. So what is number 3 on page 236? What number is number 3 like that we've done? Can you tell me? It is like number 1. So you're going to use that to do number 1. Now we're going to go ahead and do number 4 together. So turning to page 236, we're going to do number 4 together. So let's draw a first diagram for this book that's being pushed against the wall. Okay? Draw a first diagram for that quick. Okay, hopefully I had enough time to do that. We are going to have our little point mass there. That is our book. We have the going against the force of weight. They're not drawn to scale. The force of friction. Okay, so that's what your force diagram looks like. Let's write down our variables. It gives us a whole bunch of numbers. So if we read the problem, it says when 15 newtons of force is applied to a 0.5 kilogram book, the friction keeps the book from sliding down the wall. So, how do we figure out our weight here? What are we going to do? I'm going to take 0.5 times 9.8, and we get 4.9, right? And it says that the book is not moving. So this is a, there's no motion. So if there's no motion, then therefore, what can we say about the acceleration? What is that equal to? What's our physics for the day? Zero.
For the forced weight, would that be negative or positive?
It will be negative. Very good. Thank you. Okay, now if there's no movement, what is our physics going to tell us about the force weight and the force friction?
They're the same.
They're the same. So that was a key thing. So now I know my friction. Okay? And the force normal is going to be the same, but in the opposite direction. Not Newton's third law because it's on a different object. It's not a different object. They're just complementary forces. So you see how I filled in all those blanks? A lot of people would say, I can't do this problem. I only have two numbers. But using our physics knowledge and using logic, we were able to fill in everything. So now we can set up our problem. And what is the first thing we're always going to do when we set up a problem? Besides drawing a picture and listing our variables. What's the next thing that you always have to do? That people don't want, they always want to skip this, but it's really important. What do I always write?
Net force.
Yes. So set it up. So we do the y, and then you do the x. So my net force for the y is 8 plus friction. Notice friction here is positive. That's going to be force normal plus our force applied. Then you're going to substitute in everything. Okay. Alright, now we're ready to do the problem. And it says, what is the minimum force and minimum coefficient of friction to keep the book from sliding? So there, you're going to have how many different inserts? 1 or 2? How many inserts are you going to have for B? This is minimum force and coefficient of friction.
2.
2. So you're going to have the frictional force and then the coefficient of friction. So which one do we want? Do we want this one right here or this one right here? Which one has friction in it?
Why?
Why? So we're going to use this one. We're going to put in our mass. We're not accelerating. Our weight is, let's say I didn't know my frictional force. Your weight would be 0.49. What would your frictional force be? Which we already know. Our friction is going to be 0.49. So there we just mathematically proved what we did by logic up there. So that's our first answer. Now we're going to take that and we're going to break it down. Do you agree with that? So those are my answers for part B. Oh, fun! Our next problem is Logan going down the ski slope. Let's set it up. Number 5. We have an inclined plane. Logan, I don't think you weigh 84 kilograms, though. Maybe you do. Do you know how many kilograms you weigh, Logan?
No.
No. Okay. All right. So here's our slope. Go ahead and draw your course diagram. You should be good at these. The slope of our hill is 20. Let's have course normal. There's our force friction. All right. So that's your force diagram. Now we should probably set all that up. I don't know how to do one of these problems. Okay. We have our mass. So if our mass is this, what are we taking?
823.2 newtons.
Thank you. I agree with that. Okay, then when somebody go ahead and calculate the sine of x and the the sine of y. Sine of 20 times this will be y. I'm sorry, I misspoke. I should say cosine of this cosine of 20. If I could talk, that would be awesome. Times 823.2. That goes there. Sine of 20 times 823.2. Okay. Somebody go ahead and fill those in for me.
X is 281.5.
Thank you, Charlie.
For y, I got 773.55.
Okay. It's going to be negative. Okay, our friction is going to be negative. Our force is normal. Notice it's going to be equal and opposite to this right here. So I don't have to do any calculating. I can just automatically put this in right up there, right? Do you agree? Do you see how I got that number? Okay. Now we filled in all of our stuff. We should probably start doing some math. So what is the value of the frictional force? So frictional force is going to be my y. My y forces are this and that. Oops, sorry, x. Then my y forces is going to be this and that. So we need to find friction right? So is there any way we can figure out what our frictional force is going to be? Does it say in our accelerating? Can I figure out F? What do I need to know? Because I'm not going to be able to figure it out this way, like we normally do, because I don't know the acceleration. And I don't know for sure if these are equal, because it doesn't say it's at a constant velocity. So I can't just say this one is equivalent to that one in this case, like we normally do. So I'm going to have to go back to the equation. So my force normal is 773.55, and u is 0.15. So what does F end up being? I just calculated it to be this. Do you agree with my number? Sorry. Do you agree with my number?
Yeah.
Awesome. So that's the answer to part B. Now we need to calculate the acceleration. So we're going to put this number in here and solve for A.
Move your paper down, please.
So what do you get for A? How fast is it going down slope? Well, just velocity. How much is he accelerating? Black diamond.
Seven.
Yay. Good. Okay. You only need something about this problem. It's on your test, and I'm telling you there's a problem like this on your test, okay? I'm also telling you there's an Atwood and a modified Atwood on your test. So make sure you study how to do this problem. Your job this night is to do numbers 2 and 3. Okay? In that? So I'm done. Yeah, I've tortured you long enough. So I'll see you. Bye.